Okay, now we are going to discuss about how to delete element from a binary search tree. Here, first step, we have a function. I mentioned here it is delete, and verify whether the root equal to null. Because if the tree is empty, then we don't have the elements to delete, so we will send an error message. Okay, if the condition is false, that means if elements are available, then what we will do is we will collect the element from the user, and that will be stored in the variable yearly. Then I am using p is a variable to store a value. What's the use of this statement is, consider if I want to delete an element, consider if I am going to delete the element 20, after the deletion of 20, during the deletion what I have to do is I have to change the write address field of 15, because the parent node's write address field is reassigned as null. Then only the deletion is complete. So I need the access of 400. Then only I can perform a deletion on 500. Deletion of 500. So while traveling itself, I just want to collect the parent address in my hand. So then only I can perform the deletion. So for that I am using the variable p here. P is also assigned as root. Q also assigned as root. I will explain why I am assigning Q here, and then I am passing delete option. So in this case, first step is to identify where the element is located. So for that I use another function search underscore delete, and I am passing the root address as well as the element to delete. So this is a actual function search underscore delete. Normally we will get we are assigning the new variable t, not to disturb a root variable. So t is a variable that will collect the root address and comparing that value with the element. So consider the element that I am going to delete here is 20, I think. 20 is the element that I am going to delete. So comparing 20 with initially 35. So root address is 100. 100 tends to data is what? 35. 20 greater than 35, condition false. Then move on to this next step. 20 less than 35, condition true. Then so here for my easiness I am mentioning the element value. The element that we are going to delete is 20. Okay, so 20 less than 35, condition true. So what I am going to do is I am storing the value of root address, that the parent address, with the variable p. So p contains address 100. Then moving to, because it's not equal to the condition, this condition is true, that means it is not equal to the data. That means we didn't identify the data. We have to find the data. Still the searching is going on. So what I am doing is I am moving on to the left, because it's less than in the sense the element will reside on the left subtree. So t tends to left, then the element is 20. So 100 tends to left is 200, I think. So 200, then element is 20. So here again 20 greater than 200 tends to data. 20 greater than 200 tends to data. What is 200 tends to data? 25. 20 greater than 25, condition false. 20 greater than 25, condition false. 20 less than 25, condition true. Then p will be reassigned as, so in this case initially p was 100 and now it's reassigned as 200. And then moving on to the left part, because it's less than, so 200 tends to left. So p contains 200 and moving on to its left child. 200 tends to left, what is that? 300 tends to data, that is 10. So here 300 is the value that passed. So 20 greater than 10 10, condition true. If the condition is true, greater than, in the sense we will move on to the right hand side. So p equal to 300. So I reassign, because we didn't finalize the data. Some more elements are there, some more traversals are needed. So what I am doing is I am taking that parent address. Sometimes the right child may be the exact element, or further traversal may be there. So whatever it may be, we are going to store the previous element address. So p is considered as a tracing variable. We are going to use this p to trace which one is his previous node or a parent node. So p contains the previous node, 300. Then 300 tends to right. What is that? 300 tends to right. 300 tends to right is 400. So 400 and the element is passing to the function. So 400 and the element is 20. So 20 greater than 400 tends to data. What is that? 400 tends to data 15. 20 greater than 15, condition true. So 20 greater than 15, condition true. Then P equal to 3 20, the address of 20 is what? 400. Okay, now right now it is 400 is assigned to the variable P. P and traveling to the right hand side. So 400 tends to right, that is 500, and the element 20. Okay, then 20 greater than 500 tends to data. 20 greater than 500 tends to data. 20 greater than 20, I think. 500 tends to data is 20. 500 tends to data 20. Okay, 20 greater than 20, condition false. So P contains which one? 400. Previous node address is available with P. So P contains 400 and 20 greater than 20, condition false. It moves on to the else case. 20 less than 20, again condition false. Still P contains address 400. Previous node's address is available with P. So next else 20 equal to 500 tends to data. That is 20. The condition is true. That means we located the element. We are having the address of the exact element to delete. So once we arrived this particular location, then what we have to do? We have to perform the deletion operation. I am using another function, delete of 140. Okay. Okay.